My name is Ben Fathi. I'm Corporate Vice President of the Security Technology Unit, and I'm going to be talking to you today about the security progress that we at Microsoft believe we've made over the last few years and where we're going as we move forward with Vista and beyond. I am new in this job. I've been in this job for a couple of months. I ran the storage and file systems and file servers in the Windows Server division for the past 8 years. So there's 3 things that I want to make sure that you take away from this presentation. If you miss everything else, it's 3 key things. First of all, Vista is by far the most secure operating system that we have ever built. And you heard Bob Muglia say the same thing last night. I think he even went one step further and said Vista is maybe the most secure operating system ever shipped by anybody. I hope that's the case. I certainly believe in it, and you'll hear some of the details of why we feel that way. Second is that there is no silver bullet in security. Our strategy and strategy of a lot of other companies around the industry, you'll see, is defense in depth. That means you have to take every step. You have to build a fundamentally secure platform, and you have to build and take advantage of things like antivirus, anti-spyware, firewalls on top of that. Third is that security is not just about technological innovations. We're a technology company. You're going to hear a lot of technology details in here as I go through it. But it's also important to acknowledge, and I'll talk about other things we do in terms of prescriptive guidance for our customers, as well as industry and government collaborations to address issues outside of the technical arena. So I want to start by talking about challenges. There are a lot of things that we've heard from customers over the past few years on what are the challenges that they're facing in the security space, especially IT personnel. Obviously, there's always viruses and worms. That's never going to go away, and it's continuing. We're also seeing prevalence of botnets and rootkits. More and more bots out there trying to attack organized zombie machines attacking people and corporations. There is also a huge amount of phishing and fraud going on. A lot of these are financially motivated, and I'll give you some more details on this. So more and more spyware, spam, all of these are major issues that corporations are dealing with. There's also a lot of internal security challenges within a corporation. Of course, identity and access management continues to be a very hard, challenging problem, and we're doing a lot in that space, and you've heard some of that earlier today, and I'll talk a little bit about it, but not a whole lot. On top of that, IT administrators have to make sure that they patch machines, they have the latest version of software running, they have to worry about applying corporate policies, they have to worry about regulatory compliance depending on what country they're in, all the governmental requirements. And more I'm hearing, just last week I was talking to a summit of CSOs, of enterprises, and they brought out a very interesting point. They were telling me that a large percentage, in some cases the majority of their employees, are no longer employees sitting at their desk working on a PC or a laptop within a domain-joined environment. They're really people sitting from home, or even vendors just sitting at a Starbucks somewhere on unmanaged PCs that are not joined to their domain. So they do also worry about things that we traditionally think of as consumer environments of unmanaged PCs and the virus environments on that. There's also the issue of information loss and leakage, whether it's lost or stolen laptops. Just last year, there were over 600,000 laptops lost or stolen in the United States alone. You've seen a lot of the headlines about what happens, whether it's financial information getting disclosed or people's private information. It's very embarrassing for companies, and it's a big issue, liability also for them. So all of these issues are ongoing, and they're all security related. I want to switch and talk about the progress we've made very quickly over the last couple of years and the lessons that we've learned as we've made these changes. The biggest thing that we've done over the last 3 or 4 years is Windows XP SP2. In terms of the amount of engineering effort that went into it, it was the largest effort. We basically pulled all of the developers and testers and program managers off of future releases, and for several months had them do nothing but security development and we poured all of that into SP2. So we fixed a lot of bugs, a lot of obvious bugs, whether it was buffer overflows, whatever. We also added the firewall, so we improved the security of the platform significantly. I think that is obvious today. There are close to 300 million copies of XP-SP2 out there, and we have seen data showing that it is significantly less likely to be infected by viruses and spyware, not only because of the bug fixes we've put in there, but also because of the defense in depth measures that we've taken. Windows Server 2003 SP1 came a little later. It took advantage of all of the fixes that we put into SP2, but it was also a lot of other security areas that we started focusing on, especially more secure by design and more secure by default. What I mean by that is we started looking at deploying servers by role and what it meant to lock down those servers so that, for example, if I have a file server, if I have a server deployed as a file server, there's no reason that it should be listening to HTTP requests coming in. It should only be listening to file requests coming in. So we would lock down the server so it didn't even listen to those ports, so we reduced the attack surface coming into the machine. That's an example of the types of things we did in SP1 of Server 2003. Last year, we also released Windows Defender. This was originally called Microsoft Windows Anti-Spyware. It is now in beta 2. It hasn't been released yet, but it's already the most popular download in Microsoft's history. We've had close to 30 million people download it. Beta 2 came out, I think, about a month and a half ago. There's already been over 10 million downloads of the Beta 2 version, and it's helping protect our customers against spyware. It's available as a free download, and it's also included in Windows Vista. There's another item here that we don't really talk a lot about. It's called the MSRT, Malicious Software Removal Tool. This is a small application that we released back in January of 2005. It gets downloaded when you download your patches from Windows Update on a monthly basis, and it includes signatures for the most prevalent kinds of viruses and worms out there. And it doesn't fix everything, but it does a quick scan of your machine, what's in memory, and it tries to clean that. And if it does find something suspicious, it sends it does a system scan, a file system scan, to see if there's anything else it needs to clean. There have been 3.2 billion executions of this on all the machines that have downloaded it, and over 18 million disinfections. Based on this and based on Defender, there's a significant amount of data that we have collected. None of it personally identifiable information. It's just information about the state of malware out on the internet. And we're in a unique position based on the number of users we have and the number of tools that we release to collect some of this data and then mine it. Let me run through a little bit of what we've learned as a result of that. By the way, there's a white paper that we just released. It's available on the web. It's also available down in our booth downstairs on the malicious software removal tool and our learnings based on that. So, for example, the 18 million disinfections that happened on roughly 6 million total machines. So a lot of machines had multiple pieces of malware running on them. There was one machine that actually had over 250 different kinds of spyware running on it. And that wasn't the only one. There were lots of machines with dozens or hundreds of pieces of spyware running on them. The other piece of information that we found out was that 62% of the malware running on these machines was actually Trojan types of Trojan backdoor software, and the majority of those were bots. 14% of them were rootkits. So we see that as part of this, we see that the prevalence of malware in terms of virus and worms is actually coming down. We're no longer seeing the huge internet-wide attacks of things like Slammer, Sasser, Zotab. Those were really, frankly, done by script kiddies and teenagers sitting in a basement somewhere trying to gain notoriety or do as much damage as quickly as they could. Instead, what we're seeing is a lot of financially motivated, targeted attacks, a lot of times at corporations, or government or industrial espionage, people just trying to gain information. And that explains the prevalence of these types of botnets. Also, we have a lot of this information from our online crash analysis. OCA, or Watson, as a lot of people call it, is a tool that runs when an application crashes or hangs, or when an operating system crashes or hangs. We send that information back, and then we later look at it. And what we look for in some cases is, was there any malware running in memory on the system when the system crashed? A lot of times we find, yes, there was malware, and it didn't really crash as soon as it was loaded, but it caused some kind of data corruption in memory, and then later on the application crashed as a result of that. Hotmail is another source of very interesting information for us. There are 230 million unique Hotmail users. We get, on average, over 3 billion pieces of email going through Hotmail on a daily basis. And as much or more than 90% of that is spam. You'd be surprised to find out, I heard this, that 10% of all of the internet email traffic is actually generated by 3 individuals. So there's a lot of spam out there, and we look at that spam and we look at the data based on that, and that's what we've learned as a result. And a lot of the security emphasis that we put into Vista and our other security products is based on that learning. So now I want to switch and talk about our strategy moving forward and how we're addressing a lot of these issues and the malware trends that we're seeing. Our strategy is basically to build a fundamentally secure platform. So we put a lot of investment into Windows itself and our other platforms. And then on top of that, we build security products and services that are available on top of that, such as the Forefront suite of products that were announced today, or OneCare on the consumer side. On top of these technological advances that we do in the platform and additional services, we also provide a lot of guidance to customers. We want to keep our customers safe and secure and make sure they understand when they're giving out their private information, and to stop that as much as possible. So we write a lot of white papers. We develop a lot of tools like MSRT, like other tools that I'll be talking about, that are available to customers so they can do an assessment of their security vulnerabilities and address those. We also, my team also runs MSRC, the Microsoft Security Response Center, which is responsible for delivering security bulletins on a monthly basis or more frequently as needed, and delivering guidance associated with that for IT pros on how to protect themselves against vulnerabilities in the wild, against exploits in the wild. We also have a lot of industry partnerships and government partnerships that we don't really talk a lot about, but these allow us to go out and do work with governments on public policy, go after some of the spammers that I mentioned earlier, and also collect information and share information on the malware out on the internet, for example, with antivirus vendors, so that we can provide signatures more quickly when there is a threat out in the wild. So I want to talk first about technology investments, and I'm going to spend a lot of time talking about technology investments, including demos that we'll give you. There are 4 areas that we're investing in. Engineering for security is the first one. Then I'll talk about enabling secure access, protecting against malware and intrusions, and finally, protecting data from unauthorized viewing. Engineering for security. This is all about SDL, the Security Development Lifecycle. This is something we started several years ago. We rev it on a regular basis, at least once or twice a year, from the learnings that we get from postmortems that we do on issues. And until now, it's really been internal. We evangelize it internally. We do a lot of training for our developers and testers and program managers to teach them how to do better, more secure development. But we're also starting to externalize it. We're starting to, we call it productize it. By that, we don't mean we're going to charge for it. What we mean is we're going to evangelize it. We just published a new book called The Security Development Lifecycle by Michael Howard and Steve Lipner, who are 2 of the security folks in my team, that talks about all of the things that we do, the processes that we go through, and how other ISVs can also take advantage of that. There are tools that we've built as part of this process, and there's a couple of examples here, Prefast and FXCOP. Prefast is a tool that we run on a regular basis on our sources that looks for the most common types of security vulnerabilities in code, such as buffer overflows. It's really meant for C and C++ code. And then FXCOP is the equivalent of that for managed code, and it looks for things like SQL injections and other common vulnerabilities in managed code. So we've built this process, and it really is a process that goes through the entire life cycle of a project. It starts with looking at security requirements. When a project, whether it's a component or an end-to-end solution, starts at Microsoft, what we do is we assign a security buddy or an advisor from my team who's a program manager and works with that team to identify the security issues that are potentially going to happen as they design and develop this component. So then they go through a design phase. As part of the design process, they have to think through the threat modeling, which is how we look at the attack surface for a particular product or component. Does it listen on the network? Does it access files? Does it access the registry? What are the types of APIs that it has? How can somebody attack it? So we do all of that thinking as part of the design process. Then we go through, obviously, the implementation phase, where we do the training of the developers and the testers, and we run a lot of our tools that we have on a regular basis on the sources, like Prefast and FXCOP that I mentioned, but there are literally dozens of tools that we've developed that look for issues in the code. We also do security pushes. I mentioned the XBSP2 security push. We do the same thing at various points in the development lifecycle of a component. Then when we come closer to the release of the product, we go through something called FSR, the final security review. This is where my team sits down and looks at all of the work that the development team has done. We actually bring in penetration testers who are really professional hackers. They're white hat hackers, either employees of Microsoft, or we bring in vendors from the outside that do hacking of the component. They do it both as black box hacking by just trying to attack the component without knowing the internals, and they do white box hacking. They look at the sources. These are just another set of eyes who are specialists in attacking components, and they try to do that, and they file bugs against the code. And as part of Vista, we've done this, and we have, to my understanding, the largest collection of penetration testers ever assembled in the world trying to attack Vista, and we're looking at the bugs that they've generated and try to fix all of those before Vista ships. So once we go through this process, we do an RTM and sign off and release the product. I want to re-emphasize that this applies to almost every component and every product that Microsoft ships. This is not just Windows. It's not just Office. It's not just MSN. It's almost every single product that we ship. If it has network-facing components and listens on the network, or if we believe that there's any way of an attacker trying to attack it, we will go through the security development lifecycle. It's required for a lot of components and products, but it's also recommended for every single product. So once we've released the product, then we go through a phase of security response. And this is where we have plans in place for what happens if something goes wrong, what happens if there's a vulnerability, who are the people in the team to contact who are specialists and understand the code and can go and identify the problems. And if those vulnerabilities, if those exploits happen, we do go back and create a feedback loop into the SDL process to modify it for next time around so we don't have that kind of issue again. And when we do get a report of a problem, either internally or externally, we don't just fix it. We go and run our tools on, or create new tools for new kinds, for similar kinds of vulnerabilities in the code. An example of this is the WMF exploit that happened a few months ago. We went back and we already had a lot of parser fuzzing tools, but we created even more parser fuzzing tools for files and for network protocols, so we could find all kinds of issues with, for example, JPEG parsers or network protocol parsers. So I've talked enough about SDL. We do believe that the focus that we've put on security over the last few years is really yielding results. You can look at some of the data for yourself, but these are the number of important and critical bulletins that have been released before and after we put the SDL process in place for Windows 2000 Server versus Windows 2003, for Office XP versus 2003, and for SQL Server 2000. Their Service Pack 3 was really their security push where they fixed. And you can see that the number of bulletins has been significantly reduced. And this doesn't mean we're done. We are absolutely committed to continuing this process moving forward and learning more from it. So I mentioned some of the security tools that we've built. They're part of Visual Studio. I want to talk about a couple more. One of the things that we've done is add a lot of tools to Visual Studio to improve the ability of a developer to build non-admin applications. One of the major problems we have is that a lot of legacy applications just assume that you're running as admin on a system, and that's causing problems. So we've built tools such as what's called debug in zone and a permissions calculator so that you can run your code as a standard user and find out if there's any administrative issues with it and whether it can run as regular user or not. I mentioned the static analysis tools. I won't mention that again. We are also built tools that help with secure coding at runtime, not just static analysis. And examples of this, one example is the GS option in Visual Studio, which helps with buffer overflow problems by putting zones around buffers in memory and detecting when there's a buffer overflow problem. So the next area I want to talk about is fundamentally secure platform. And I mentioned engineering for security. I'll talk about service hardening. This is another area that we don't really talk a lot about, but it's really key. One of the ways that malware gets into a system is by taking advantage of vulnerabilities in service code running on the system. The UPnP problem we had a couple of years ago is an example of this. These are services that run on a system that do anything from detecting devices to doing file serving, for example. And because they have administrative privileges, once a piece of malware finds a vulnerability and breaks into them, it can then take complete control of the machine. So what we did as part of Vista is we said, wait a minute, these services don't really need to have access to everything on a machine. If I'm the SRV service doing file serving, there's no reason that I need to be touching registry entries over here. I know exactly what ports I should be listening to, and I know exactly what registry entries I should be reading and writing. So we put ACLs on the directory entries, on the ports, and on the registry entries that it wasn't supposed to touch, and we gave it access to only the things that it should touch. That's just one example. We did this with every service in Windows so that even if a piece of malware breaks in and takes over the service, it can't do real widespread damage. It can only damage that specific protocol or that specific set of files that it touches. Another area that we've worked on is improving kernel security. And this really goes a long way in improving the rootkit situation that I mentioned earlier. We want to make it harder for rootkits to get into the system. So we've done two things specifically. One is requiring driver signing on x64 machines. Today, when you get a device driver, a lot of times it's not digitally signed. So it could be modified after it was released, or it could be a hacker that's downloading something and getting it into the kernel without your knowledge. On x64 systems in Vista, we require kernel mode signing. What that means is there is a digital certificate when we go to load this thing, and we can go and revoke those certificates if we find, for example, that a piece of malware made it into that driver, or if there's vulnerabilities. So it's a lot more secure to run those drivers in the system. Kernel patch protection, also called patch guard, is another area that we've invested in. There's a lot of pieces of malware that get into the kernel and they modify kernel code, whether it's APIs for file system access or registry access. They actually modify the instructions and they redirect to the malware so they can do nasty things. What we do with patch guard is we completely stop that. We basically have hashes so we know what the code is supposed to look like. And with DEP, data execution prevention, we mark those pages so malware can't modify them. So again, rootkit, we're making it a lot harder for rootkits to get into the system. Now I want to switch gears and talk about enabling secure access. A large area of this is identity and access management, which is a very complex area, and you've heard a lot about it at this conference with things like Active Directory and Forefront. A big part of this is a trust ecosystem, which is our efforts in turning security from a defensive measure and a defensive technology into really an enabling technology. A big part of this was Active Directory Federation Services, ADFS, which was shipped as part of Windows Server 2003 R2 at the end of 2005. What we did here is we have the ability to take individuals working in different Active Directory domains and allow them to share information securely and seamlessly as long as they have an AD identity. So this really turns the security situation around and helps you share information rather than just trying to protect yourself. I have another slide, and we have a demo on the Certificate Lifecycle Manager, so I won't drill down into it here. In the area of access and authorization, we've also done a lot of work in Vista. One of the areas that we've invested in is the auditing improvement. So we have a central, secure auditing service that the system and applications can use, and it can be used later for forensics or for trying to have accountability of who did what when. There's a lot of improvements in Vista in that space. In the area of authentication, one of the things we've done is really deeply integrated smart cards into the system. So pretty much for any area that we required a username password in the past, you can now do the same thing with smart cards. So corporations can deploy RPC over HTTP or OA, all of these scenarios with just smart cards, which is obviously a lot more secure than passwords. User account control is our attempt to get more and more people to run as standard user. I mentioned this earlier. Everybody today runs it as administrator. This is a major security problem. So what we did is we created an environment where when you install Vista, the built-in administrator account is disabled by default. The first user that we create is something called a protected admin. And every user after that, second to nth user, is a standard user. A protected admin means you have administrative privileges, but the tokens that you run with are standard user tokens. So if you try to do anything that requires admin privileges, we detect that. Let's say you want to change a configuration or you want to start a tool that changes system configuration, we put up a pop-up and require your consent, and we give you some information about what that's doing, so that if a piece of malware tries to do that, you would detect that and block it. For a standard user, you basically don't have that ability because you don't know the administrator password. And so what we do is we give you a different dialog, and you'll see a demo of this that requires both an admin login name and a password. And you can go to your admin, get that, and they can allow you to do it. Or in the most standard case, you really don't want a standard user installing stuff on their machine because they don't know what they're doing. They're blocked. They can't do that. So malware can't make it onto the machine. There are two real scenarios for this. One is locking down desktops in a corporation, and the second is parental controls. And there is UI for parental controls for consumers in Vista as well, so that children we can control what times they surf the web or play games. All of that UI is built in. And we'll show you a demo of that as well. The one area that's beyond Beta 2 that's for RC1 we'll also demo to you is something called the ActiveX installation service, which our customers gave us a lot of feedback. They said, we really want standard users in corporations to be able to install ActiveX controls, and we've built the ability to do that into the RC1 release of Vista, and you'll see that. Network access protection, NAP, is built into Vista and Longhorn Server, and it's also going to be available for XP. Moving forward. This is the idea that you really want to control the devices and laptops coming into your corporate environment and make sure that they're passing corporate policy, whether it's patches that need to be installed or certain versions of applications or signatures for their antivirus software before they're given access to your corporate data, so that if they have malware, it can be cleaned. So we quarantine the machines, we put them on a private network, and they can only talk to the NAP server and get updated and fixed before they're given access to the rest of the network. So I mentioned CLM. I want to talk about this a little bit more. Certificate Lifecycle Manager is currently in beta, and it's going to be available early next year. It's a product that we got through an acquisition last year of a company called Alacris. Basically, it's an administrative tool for a single place where your administrators can provision, manage, and maintain the digital certificates for applications and for people. And an example of that is smart cards. So users can get their smart cards activated, their PINs reset, and administrators can specify in a single place what the policies are around those certificates. So what I want to do is get Amesh Mansakani to come up and give you a demo of CLM. Hey, Amesh.
Thank you, Ben. So I'd like to talk about how we are addressing a common organizational need, that of provisioning users with the digital credentials they need to do their jobs, and managing those credentials throughout its complete life cycle. Things like certificates on smart cards, secure wireless, and secure email have been a complex and expensive task to manage in the past. But Microsoft's Certificate Lifecycle Manager enables us to provide an easily administered identity management solution for the Windows platform. Now, there's two things I want to go over today. One, how easy it is for an administrator to modify these profiles. And two, how simple it is for an end user to request their digital credentials through an online provisioning system. So let's go through the first scenario. Let's pretend I am an IT administrator in the Contosa organization. What you see here are common links to tasks for credential management, such as administering a user, being able to view and approve requests, or even manage certificates and smart cards directly from this single page. Now, my organization has created a workflow to automate most of these actions here. And we've done this through what we call a profile template. Let's dive a little deeper into that. Now, you can see we have two profile templates available here. One for distributing digital certificates, which is secure wireless over here, and one for for distributing smart cards to every new employee. We're going to look at the smart card configuration here. Under the certificate template, we have two certificates available, one for smart card logon and the other one distributed for secure email. We can also modify smart card configuration, such as how is a PIN being selected. According to this, we're actually requesting that the user provide a PIN during the provisioning process. And on the upper left-hand side, we have many different policies that go through the complete life cycle of a smart card. We can define how a smart card is treated if somebody loses it. We can also define temporary cards. So what happens if you actually leave your smart card at home? We also have an online update policy, which we can go ahead and update attributes such as a username or even somebody's email address automatically to a smart card. Now, each of these policies has a workflow associated with them. Let's look into the enrollment policy here. Underneath the enrollment policy, you can see we have self-service enabled. So any end user can go ahead and provision their own smart cards. We also have some applet management and data collection. So here what we're asking is for employees to enter their employee ID during the provisioning process. And also, we have document printing available. So if at the end of the day you want a user to be printing a document or a PIN letter, you can do so from here. Now you can see how simple it is for an administrator to be able to modify these profile templates directly from the management solution here. Now let's pretend I'm a new user in the Contosa organization. And what I've done is I've gone through my orientation and I've received a blank smart card. And my manager has given me a temporary username and password to provision this smart card. So first I'm going to go ahead and log in as the new user. Oh, let's try this again. Oh, wrong username. There we go. And I'm going to insert my smart card into the reader here. As you can see here, I have the same similar portal, except the functions that I'm allowed to do here pertains directly to my digital credentials. For example, I can request for a new set of certificates, or I can go for a permanent smart card, which I'm going to do right now. And as you can see, the first thing it asks me is for my employee ID. As you remember, my administrator had actually set this up for me in the profile template. I'm going to go ahead and click on Next. And what it's doing right now, it's actually going and initializing the smart card, clearing it for the first time used, and it's putting any applets on the smart card that it needs. After that, it's going to actually ask me for the PIN, which again, we said we want the user to put the PIN. Click on OK here. And now it's generating the keys directly onto the smart card. Once that is completed, it goes to the certificate authority, picks up the two certificates, and drops it directly onto that smart card. And that is actually it. It's that simple for an end user to go ahead and be able to get a smart card provision for themselves. Now, in my previous organization, I actually had to walk to a different building and wait in line for about 20 minutes and get my card provisioned. Now, what happens if I'm in a different country or a different location that I can't even access that? With Microsoft Certificate Lifecycle Manager, it's much easier for me to do, and there was no administrative interference in that. So, with the combination of Microsoft Certificate Lifecycle Manager and the Microsoft Certificate Authority, and with third-party smart card vendors, deploying a certificate infrastructure has been easier than ever before. Thank you.
Thank you, Amish. Thank you. Now I want to talk about protecting against malware and intrusions. This is really about threat and vulnerability mitigations. And there's three different areas. I'm just going to talk at a high level here. We're going to drill down into each of these. It's about prevention, and by that we mean stopping both known and unknown threats from getting onto your system. Remember that defense in depth. It's about isolation. The best example I can give here is virtual PC and virtual server. A lot of people are starting to run their workloads on virtual servers because that environment is totally isolated. If something goes wrong there, it can't affect the rest of your workloads running on the same physical server. There's a lot of investments we've made in this space as well. One area that we don't really usually talk about in security is recovery. This is about, okay, let's say something went wrong and we got into a bad situation. How do we get back to a known good state? There are a lot of tools built into Vista and Longhorn Server. You can do individual file backups. We have automatic scheduled backup set up, so you can just set up a disk and forget about it. We have complete PC image-based backup, so you can quickly recover the entire PC at a block level if a virus hits, for example. We have system restore for getting back bad drivers into a good known state. There's a lot of different investments there as well. So drilling more down into malware protection, what have we done in Vista? IE protected mode is a good example of this. What we've done in IE is by default, when you run, you're in protected mode. What this means is if you click on a website and a piece of malware gets into your system, we automatically redirect all of the file and registry accesses into a temporary folder under temporary internet files and lie to the applet or application that you've downloaded so that it's virtualized. It thinks it's writing to system configuration and registry entries, but it's really writing to a temporary location, and it's not changing the configuration of your system. So it behaves as it thinks it should, but it doesn't hurt you. Windows Defender, I talked about this a little bit earlier. This is the anti-spyware solution that's built into Vista, and it's on by default. It helps protect your machine. Windows Firewall is also built into Vista by default, and it's bidirectional. You can do both inbound and outbound firewall protection. By default, the inbound is on and the outbound is off because we got the feedback that most users don't know how to turn on the outbound and what ports to deal with. It also has IPsec integration in Vista. So if you have IPsec deployed in your corporation, you can go to a single place and manage your firewall with IPsec. And it can be turned off by third parties or by end users or by OEMs. Security Center is another area that we've invested heavily in. This is a single place where a consumer or a standard user can go and get a yellow, red, green light on the total security status of their machine. Basically, if it's green, you don't have to worry about it. You know everything is okay. If it's yellow or red, you know there's something wrong. You can drill down and it'll tell you your antivirus software is out of date, your signatures are out of date, or it's been disabled. You can go turn it back on very easily from within a single place. So a lot of this is about simplifying the security for users. Another area that we didn't really talk a lot about but is included in Beta 2 is something called ASLR, Address Space Layout Randomization. It rolls right off the tongue there. What ASLR means is basically in Windows XP there are hard-coded addresses that are known to malware for where we load system libraries. So that if a piece of malware gets into the system and attacks, it knows what address to jump to get it back into the system. So it can do a lot of damage. With ASLR and Vista, what we do is every time the system boots, we actually put the system libraries at a random location, which is 1 out of 256 possible locations. So if a piece of malware gets in, it has a 1 out of 256 chance of actually hitting the right location. So this really reduces the return to libc type of attacks that have been prevalent in the past. And it also works really well with data execution prevention, DEP, or the NX ability of the hardware. So it's a really great investment, and we think, and it's on by default, and it's available to all applications and to the system. Also in the area of preventing malware from getting on your system, obviously you've heard a lot about Forefront yesterday and today. I'm not going to talk about it here, but it really goes to our defense in depth strategy. Everything I mentioned up to now was in the OS. It was part of the fundamentally secure platform, but on top of that we provide additional services and solutions for both consumers and businesses to deploy. Last but not least, I want to talk about protecting data from unauthorized viewing. So there are 3 areas that we've invested heavily in the past, and we continue to do so. The first one is RMS, Rights Management Services. Remember the example I gave earlier in the talk about 600,000 laptops being lost or stolen in the US? Well, RMS gives you the ability to protect data throughout its lifetime, whether it's a document or whether you grab that document and drop it as an attachment into a piece of mail. You can put protection on that document. It can be encrypted, and you can have a list of names of users who can access it, and you can specify in a fine-grained way what access they can have, whether they can read it, write it, print it, forward it. All of those things can be specified. It's been out there. It's available today. In Vista, the client is integrated into Vista itself, and it's available as a platform. So we're working with a lot of third-party ISVs to integrate it into their applications. We're hearing a lot of verticals, for example, CAT applications, that are interested in protecting their CAT files. There are several solutions available there. And as we move forward, you're also going to see a lot more integration with other products. The one example I gave here is in Office 12 and SharePoint. You can actually, by policy, have a document library that has protection through RMS on all of the documents. So even if somebody drops a regular document on there, we protect it through RMS, through policy. So an administrator can say, only this group of users can pull documents out of this document library. So it's really powerful. EFS goes to a slightly different scenario. It's really meant for machines that have multiple users using them. It does both file and folder encryption. It's been there since Windows XP, and we've consistently improved it. In Vista, what we've done is added the ability to store the EFS keys on a smart card. BitLocker is a completely new investment we've made, and it's really about hardware-enabled data protection. There's a chip called a TPM, a Trusted Platform Module, that's becoming more and more available on both laptops and servers. And what we've done is taken advantage of that to build full volume encryption into the machines. So, and to have secure, safe boot using that hardware encryption technology. The scenario in Vista, again, is lost or stolen laptops. Even if somebody steals your laptop, the entire volume is protected and encrypted, so they can't try to take that out, plug it into another system, and try to steal the data off of it. It also has server scenarios. Customers tell us that they have a lot of branches and remote locations, like a financial institution or a bank that's in a grocery store somewhere, where they don't have physical security of their servers. Those servers can be stolen. And guess what? They're usually domain joint servers, or maybe even DCs, and they have credentials, they have user information on them, they have private financial information on them. So in Longhorn Server, we take the BitLocker technology and apply it to those servers as well. So you can enable servers in remote offices also being encrypted totally, so even if they're stolen, they can't steal the data. Now what I'd like to do is ask Alex Heaton to come out and give you a demo of some of the areas that I've been talking about in Vista Security.
I'm going to demo for you how Windows Vista makes it easier to run as a standard user, so your users will be more secure, how Internet Explorer 7 Plus and Windows Vista will help protect against exploits and reduce malware on the machine, and how BitLocker will help protect information on hard drives. First, I want to actually go back to Windows XP. Most people run Windows XP using a full administrator account, and that puts the machine at greater risk of malware and other threats. So to demonstrate this, I'm going to launch this, what I think is a game I downloaded from the internet called Going Bananas. And when that game comes up, you'll see actually it turned off the firewall. And I wouldn't have known that unless I had the security center up to show me. So the point is, when you're running with your full administrator privileges, you're at more risk because software that you are running can do anything you can do programmatically without you even knowing it. So the solution to be more secure would be to run using a user account, what we call in Vista a standard user account. And most people agree that this would be a more secure way to run, though the problem is it's very difficult on Windows XP to run unless you're an administrator because a lot of the things don't work, which I'll demonstrate. Even simple things like trying to view the clock to change the time zone, you get an access denied message. If you want to change your power settings, for example, to do a presentation, when you go into presentation mode, you believe you have the permissions to do that, but when you click OK, you get an access denied. So you imagine you couldn't go into presentation mode to do a presentation as a standard user. And if you went to install a program, you wouldn't want to have your users have permissions to install their own software. But you get halfway through the install before you find out that you don't have permissions to do it. But probably the biggest problems that organizations face when they try and reduce administrator privileges is that many legacy line of business applications just don't work. So I'm going to run a typical line of business application, and on startup, it's trying to access a protected registry key, and it just fails. Actually, this is not a critical error. I'm able to bring up the application, and it appears to run. But if I make a change and try and save the data, I get an access denied message because it's trying to save the data back into the program files folder that the standard user doesn't have access to. So this application is basically unusable for a standard user. And you can imagine if this was a legacy application, you may not have the code for it anymore to modify it to make it run. So now I want to demonstrate on Vista as a standard user how you have the same level of security with much greater usability. So I'm going to run this same game, and you'll get access denied because you're running as a standard user. You don't have permissions to turn off the firewall. But a lot of things do work. So for example, I can view the clock. You can have this multiple time zone clock in Windows Vista. I can change the time zone, which isn't something that you could do on Windows XP as a standard user, so your time would always be out of sync if you're traveling. Though if I want to change the date and time itself, you'll see that has a shield icon, which indicates this is an administrator-restricted operation. And you wouldn't want a standard user to be able to change the time because many compliance and auditing things require an accurate timestamp, for example. So if a standard user tries to do something, they'll be blocked from doing it, but they have something here called the over-the-shoulder credentials prompt, where an IT administrator or a parent in the home could give their consent to do it. And there's a few different authentication mechanisms that they could use. They could use their username and password. They could insert the smart card of the administrator. And also, Windows Vista has a new concept of credential providers where third parties can augment the authentication mechanisms with their own code. So a developer could create a fingerprint reader for Windows Vista. So this is the first example of a credential provider for Windows Vista from UPEC, who is a manufacturer of fingerprint sensors inside laptops. But this is how also other one-time authentication mechanisms could be extended in Windows Vista. But let me show you how it solves the application compatibility problem. So I'm going to run that same legacy application, and it's just going to come up without any failure. And when I go and save the data, it successfully saves the data to the program files directory, even though actually standard users still don't have access to program files. The way that worked is in Windows Vista, we have a new technology called file and registry virtualization. And the way that works is if instead of giving an access denied message when a program tries to write to a protected area like parts of the registry or the program files directory, instead of just giving a hard failure, what we do is actually redirect that file into a per user location inside their user's profile. So this is the program files folder. You can see I, as a standard user, don't have access to this folder, but it redirected it when the application ran. And the way I can tell that is because this compatibility files link appears. And if I click that, that's going to take me to the virtual store inside the user's profile, and I can see the files here that I created. So without making any modifications to this legacy application, it's just going to work for a standard user. So we've done a lot of things under the name user account control to make Windows Vista work much better for a standard user, so you can run those users in a more secure and more manageable mode because they can't install their own software or make unapproved configuration changes or policy changes. We've also done a few things to make it more secure for the administrator as well. And this is something you might have heard a lot about in the news, about user account control causing a lot of prompts when an administrator tries to do certain things. So let me explain those prompts and the things that we're doing to reduce those. So if most of the time when you're an administrator doing your normal work, your Outlook, your email, you're not going to get any prompt. But if you do something that's going to do a system-wide change or really an admin task that requires administrative privileges, that application is going to prompt you to make sure it's you wanting to do that and not malware trying to do something on your behalf without you knowing it. And there's 3 types of prompts depending on the type of program that's trying to run with administrative privileges. The first thing I'll demo is an unsigned application. An unsigned application is the most likely to be malware, and this is something you really want to think hard about before letting that run with administrative privileges. Now on Windows XP, this would have just run without you knowing about it, but on Windows Vista, we're going to prompt you and tell you that it's requesting administrative privileges, and it tells you that this is something you need to be worried about and makes you opt in to allow it to run. So I'm going to cancel out of that. The second type of prompt is for a signed program. So if there's a valid certificate from a trusted publisher, we can pick up the name of the program. We have a lot less of a harsh warning. We can pick up the icon of the application, so you can make an informed choice if you want to have this application run or not. And then the third type of prompt is for an OS component. So if it's an OS component, we have a very safe-looking green background. We identify this as part of the operating system, and you should feel more confident allowing this to run with full administrative privileges. So that's the security reason behind it, but we still get a lot of feedback that people get too many prompts from different applications and from the control panels, and so we're doing a lot of things to reduce the amount of prompts. In Beta 2, there's a lot fewer prompts than there were in previous beta builds, and in RC1, which I'm going to demo, there's going to be even fewer prompts. So if you notice, this firewall application prompted me when I just want to take a look at it. And also, this is something, if you follow user account control in the news, if you want to delete a desktop shortcut that's part of the public desktop, when you go to delete it, you get multiple prompts. This one you'd get on XP because you have to confirm that. But then it's saying you don't have access because you're not running as an with your full administrative privileges at this moment. You have to opt into that, then approve the dialog, and then it will delete. So people didn't like that, so I'll show you how in Windows Vista RC1, which will be the next major public release available, that will be even better. So I'll delete that, and you'll see one click The desktop shortcut is deleted. So that's how we're going to make the administrator have fewer prompts on Windows Vista RC1. But we're doing even more things in RC1 that's going to make it easier for the standard user to run. So I'm going to switch into a standard user account on RC1. One of the top pieces of feedback that we got from our beta customers, including some of them that I see in this room, is that we've done a lot of things to make it easy to run as a standard user, but they still had one problem, which is they might have hundreds or thousands of ActiveX controls in their environment, and they want the standard users to be able to install ActiveX controls. So we're announcing a new service here today that's going to be in RC1 called the ActiveX Control Installation Service that's going to allow standard users to install approved ActiveX controls. So here's a typical scenario. I'm an employee. I want to log into this partner website. They use an ActiveX control to do the ordering. But I'm a standard user. I can't install the ActiveX control. I'm going to hit cancel. And then error, I can't load that control. So that was basically the way it would be on XP and in Windows Beta 2 that people have seen. But with the ActiveX control installation service, I'm going to switch, and now I'm playing the role of the IT administrator. I can see in the event log that an error has been created, that a user is trying to install an ActiveX control, and it includes the path to the cab that they're trying to install. So I can copy that domain, go into the ActiveX installation service policy, and add this new site. To set a few parameters that will be more friendly in the final version. Click OK. Now when I refresh that page, I don't get the UAC prompt. I have permission to install it. I still need to opt in to confirm this is a trusted publisher. But then there you go, the ActiveX control installs. So that's really going to help organizations that are trying to move to standard user privileges. And that is how user account control is going to make it easier to run for standard users. And now I want to show you some other things in Windows Vista, specifically how let me switch here to standard user account. I want to show you how Internet Explorer Plus in Windows Vista is going to limit the installation of malware and the ability of malware to exploit vulnerabilities in code. So this is a typical user scenario where malware writers are using multiple ways to try and trick the user into installing some malicious code on their machine. The user starts with a spam or phishing mail telling them they have a great offer to get 1-penny photos. So I'm going to try and run this offer, and it's asking me to click here. And when I click this, what it's going to do is actually try and, I'll expand that, bring up the, it's going to try and exploit a vulnerability in the ActiveX control to add a piece of malware into my startup program, doing what we call a drive-by download installation. So I'm going to click here. It looks like nothing happened, but actually evil.exe got added to my startup folder using a vulnerability in a control that was already on my operating system. And again, it's trying another way to trick me. It says if I'm having trouble, click here to get help. I click that, but it's actually a link to another piece of spyware. I click that. I allow it to run, and then it's spyware. It can do whatever its attack it wants to do. So on Windows Vista, we have something called protected mode that runs Internet Explorer in very low privileges. It only has access to write to the temporary internet files, the favorites directory, and a few other places, and it blocks those types of drive-by downloads. So I'm going to bring up the startup folder again of my Windows Vista machine, go through the same steps, and your first thing you'll notice is a new technology called ActiveX opt-in. So a way that malware writers would attack a website, use a website to attack the user before, is they would try and use an ActiveX control that has an exploit that's already installed on the user's machine. With ActiveX opt-in, you have to opt in the first time you use a control, even if it's already on your machine. So I'm going to allow this program to run. And now the web page is going to try and exploit that ActiveX control because it's running. And I'm going to click the link that should have installed the malware into my startup folder, but you can see it's not there because it wasn't allowed to write to my startup folder because of the running in low permissions. And then when I try and click the same link again, that's going to launch that other spyware. The malware comes up, I get a few warnings, but before I can download it, Windows Defender detects it and catches it as soon as it starts to download, so I can't even get very far to download it and run it because it's going to tell me this is a known piece of spyware. So there's multiple layers of protection in Internet Explorer that's really going to help limit the amount of attacks that are going to be possible through Internet Explorer. And finally, I want to demonstrate to you BitLocker that's going to help in the situation that Ben talked about of 600,000 laptops being lost or stolen in the United States every year that have confidential information, customer records, patient records, many things. So if you get a stolen laptop, and even if the account is password protected, you can take that hard drive out, pop it into a different computer, and easily just browse the contents of the hard drive. There's no protection. One of these partitions is BitLocker enabled, where the complete volume of the hard drive is completely encrypted, even all the operating system files. And Windows Vista can't even tell how many files are on it, what size the hard drive is. It's completely inaccessible. It's completely encrypted. And just to sort of mathematically prove that it's encrypted, this animation shows all of the ASCII characters 0 through 25 in different sectors of the hard drive. And you can see there's a lot of chaos. There's a lot of information on this drive. There's interesting looking information on this drive. I'm going to use that same tool to analyze a BitLocker hard drive. And you can see it has a smooth distribution of characters from 0 to 255, mathematically showing that it's a very strong level of encryption. So those are just some of the things in Windows Vista that's going to make it more secure for you and your users. User account control, running as a standard user, better IE protection, and protection for your information with BitLocker.
All right. Thank you, Alex. That was a great job. Is that cool or what? All right. Now that we've talked about all the cool technology investments we've made, I want to remind you that security is not just about technology. And I want to talk about a couple of other areas. One is prescriptive guidance. We actually spend a lot of time doing education and training, whether it's through websites or in person for our customers. There are over 9 million unique visitors each month to Microsoft.com looking at our security content on our websites. And in the last 2 or 3 years, over 2 million IT pros have been trained using the materials either on our websites, online classes, or in person. And we also build tools. A couple of examples of that. One example is the Microsoft Security Assessment tool that actually looks at your network, looks at your computer, and gives you an idea of your vulnerability situation on your machines and helps you protect yourself. We've also launched a security guidance center for small businesses last year. So there are a lot of different areas. We have documentation for developers on security on MSDN. There are 3 new things that I want to mention. I mentioned this earlier. I'll mention it again. The Security Development Lifecycle, a brand new book, is available downstairs that talks about the SDL. There is a white paper that we published a couple of weeks ago during WinHack that talks about in more detail about a lot of the technologies in Vista that I just described here and Alex showed you. And finally, there's a white paper that we published just a couple of days ago or yesterday on the MSRT, the malicious software removal tool, the trends that we've detected and the data that we've seen by running this tool on all the billions of iterations of its execution. So we take prescriptive guidance really seriously, and you can go to Microsoft.com/technet/security to see some of the prescriptive guidance there. Finally, what I want to talk about is another area, which is industry partnerships and government partnerships. We also work very closely with a lot of our industry partners and governments across the world to do law enforcement. It's a global issue, and we don't really talk a lot about this. So in the area of law enforcement, for example, there have been over 300 worldwide law enforcement actions against spammers and phishers that we have helped in. And there's been over $1 billion of money awarded to Microsoft against these spammers and phishers that we turn around and invest back into our security efforts and make available to the industry. We were also instrumental in actually arresting the authors of the Zotop and Sasser worms. So we were the ones who provided a lot of the information to law enforcement to actually identify those individuals and arrest them. In terms of industry partnership, I want to announce today a formation of a new effort called the Microsoft Security Response Alliance. In the past, we've had several different efforts under different umbrellas and different names, such as VIA, the Virus Information Alliance, or GAIAS, the Global Internet Association for Internet Safety. There are lots of different names, lots of different efforts that we have with ISVs, with antivirus vendors, and what we've done is we've collected all of these, our government security programs, collected them under a single umbrella called MSRA that's going to make it easier for us to collaborate in the industry and with governments and provide information to our customers. Now, as part of this, I want to talk about consumer awareness. It's something also that we spend a lot of time and think about. We partner with consumer advocacy groups like iSafe and the National Center for Missing and Exploited Children to provide consumers with information about online safety, how to protect themselves. And now I want to show a quick video. Roll the video, please.
In the big online world of computers, your little ones can get in trouble if they're not careful. They could open an attachment that contains a virus, be exposed to inappropriate material, or even communicate with online predators. But you can help your little ones be safe on the web. Talk with your family about online safety issues, have clear rules for online behavior, and keep the family computer in the open. For tips on protecting your family on the web, go to staysafe.org.
All right. That was a quick video that we made, and as you saw, there's nothing about Microsoft on there. It's not Microsoft branded. That we take our security responsibilities very seriously, and this is an effort that we've provided this video to governmental organizations so they can help inform the consumers. So the last slide I'm going to put up here is our roadmap. I've talked about some of these, some of the tools and solutions and technologies that are available today. There's a lot more coming in the future. It's just here as an eye chart so you can look through all the investments we're making.